On the homework assignment.
39.
Which one?
39.
39. 12i, and then in parentheses some fraction stuff. Is that the one you're talking about?
No, that's
Different section.
Wait, which
page
one?
570.
Page 570.
10.1?
No.
Page
Okay, I see.
Yeah, 39.
Okay, so we have the fifth root of 5x plus 15. I had a feeling someone would ask about this one.
Yeah, because I got stuck on that part where you can't do the AC method.
Okay. 2x squared plus 12.
Plus
This is a good problem. So this was out of the section on radical equations. And this is hopefully obvious to you that it's a radical equation. And so the first step is for us to isolate a radical. So I'm going to isolate one of the radicals. That's already done, right? You have a radical by itself. In fact, both sides are isolated. So the second step is to raise both sides to the fifth power in this problem. Raise to fifth power on both sides. So I take the fifth root, 5x plus 15. I raise it to the fifth power. On this side, I take the fifth root, 2x squared plus 12, and raise it to the fifth power. The roots will go away on both sides, right? This. And you'll be left with 5x plus 15 equals 2x squared plus 12.
Yeah, this is where I got stuck with that 2x
Okay.
squared.
And we're actually going to be doing more solving equations like this today. So it's a good thing we may as well practice on this now. So what type of equation is this? Anybody recognize what we call this is quadratic, right? It's quadratic because you have a squared up here. And the standard technique to solve quadratic equations, okay, most of the time, is to get everything to one side, get a 0 on the other side. So what we also do is we look at the number in front of the x squared, which is a 2. It's positive. So I'll leave this over here on this side, which means I want to try and bring everything over to the right side. So I'm going to subtract everything on the left side, or not subtract because they're both positive. If one of them is positive, I would add, right? Here I'm going to subtract 5x, subtract 15. That comes out pretty good. Subtract 5x, subtract 15. So I'm just lining things up. There's no x on the right side, so I can't subtract 5x from anything. 12, take away 15 here. I get nothing on the left side. My left side should be a 0, right? The right side should be 2x squared, then what?
Minus 5x.
Minus 5x, put it in descending order. Then?
Minus 3.
Minus 3. Is that all right? Just make sure it's in descending order. Highest power of x going down. And now, like I said, we're going to talk about the different ways to solve this, solve quadratic equations. But everyone should at least know how to factor this. I've been saying that for a while, haven't I? Let's see. We take AC method. We take the 2, the -3, we multiply them. What I showed you was -6, and then here, -5, right? -5 from this. Come up with two numbers that multiply to be -6, add up to be -5. So how about -6, +1?
That works.
Works. So these are my two numbers. Now, depending on how you learned it, you know, some people learn a shortcut a certain way. Some people do it by grouping. So we'll just take a vote because we're going to be doing more of this, like I said already today.
So I would write it 2x squared plus x minus 6x plus 5x minus 3.
Close.
Is
What-
that not right?
What you're doing is the grouping technique, okay? So what the grouping technique says is you see the negative 5x,
Mhm.
you're going to rewrite it using these two numbers.
Right,
So you use the 1x, and then you said minus 6x, right? You should not have a negative 5x in there after that. So what you're doing is you're leaving the front,
oh, I'm adding, okay.
and I would do negative 6x plus 1x minus 3. See, the ends stay the same. The middle term are these two numbers. Now, I did negative 6 first and then positive 1. You could do positive 1 and negative 6.
So you don't put in that negative
No.
5x.
Because look, this is negative 5x.
Right,
Right?
okay.
Yes.
Is this still step 2?
We're in actually step 4. Step 3 we skipped, right? Skip that. Step 4, solve. So I still need equals 0 here. Okay. I think I'm on. And then for grouping, you go take the first two terms, try and factor those.
2x,
So you can pull a 2x out,
x minus
left
3.
with x minus 3, and then out of the second one, this is important, this is a little
X
minus 3.
x minus 3 is what you need. What do you pull out to get an x minus 3? Positive 1. And then you have your x minus 3 equals 0.
Okay.
Yes.
On step 4, at the beginning of solve, what did the negative 5x become?
What did it become?
Yeah, what became of it?
Like from here to here?
Yeah,
It became these two.
based
This is your AC method for factoring.
based on the crisscross.
Yes, these two numbers.
Okay.
Now, this course, I was just sitting in my office before class began, looking at what we're going to go over today. I'm sitting there, I'm scratching my head because how many of you learned in 0302 how to factor? At least you were exposed to it, you were taught how to factor. Yes? Okay. So we're supposed to today do factoring again so we can solve some equations. It just kind of seems like if I expect for you to factor when we walked in here, then why are we going to factor again? But I guess the point is that we still have trouble factoring, right? It never goes away, so we need to keep seeing it. So if these steps, if all this is still giving you problems, you need to make sure you're asking questions, that you get it clear, because to succeed in college algebra, you've got to be able to do this right here. Now, what do I do from this step? If I get x minus 3 in both, what do I do?
Find what's common and take it out.
Okay, find what's in common, write that down, and then a new set of parentheses, and you put what in there?
What's left over?
The two things in front, 2x
2x
plus 1.
plus 1. And then here we set it to 0.
Set each of those to 0. Where did this come from? So I set x minus 3 equal to 0.
This is step 5, right?
2x. I'm still solving the equation.
Okay.
Yeah, I'm still solving. So I take each of the factors, set them equal to 0. The first one, you just add 3 to both sides. And you get x is 3. So that is one potential solution. This one, I subtract 1 first. And then do what?
Divide by 2.
Divide by 2. So you get negative 1/2. And then you check them. I'm not gonna check them, but I believe they both work.
Mhm, that's right.
Yeah, they both work. Did I tell y'all about about my little project I was gonna go hunting this past
Oh,
weekend?
yeah, how did it go?
It went all right.
It worked?
It was harder than I thought it was gonna be. My video worked, but it was a sort of a disaster because the recoil from the gun popped the battery pack off, and
Oh.
I wasn't anticipating that. So, but we got video at least of the shot. We didn't after that. There's no video.
What did y'all get? Focus off.
They were shooting hogs
Oh,
and then deer and then dove hunting. So, but I was more excited. I got to shoot a lot of guns because all these guys are like, this is my neighbor and all his friends, his A&M buddies. And so like they're ready for World War III, basically. Yeah, like thousands of rounds of ammunition, and like they all had like multiple guns. And so I got to shoot like every type of gun this weekend. It was pretty fun.
Sounds like my friend is getting prepared for the zombie apocalypse.
Yeah, some sort of like a prepper. All right. That okay with homework then? Anything else? Okay, we wanted to, we need to talk a little bit more about our complex numbers. And one of the last things we talked about, well, not last things, but the main idea that we were supposed to have taken away from last class was the idea that now this imaginary unit I, that it is the number that when you square it, you get -1, right? That was the idea. And we learned how to add these things and multiply. And the one thing we didn't do is divide. So I'd like to show you how to divide complex imaginary numbers. Division. All right, so let's start off with something like 3 plus I divided by 2I. How do we divide that? Well, here's the technique. What we want to do is we want to take the denominator, whatever it is, right, 2I, and let's multiply the top and bottom over here by I. Now, let's just see what happens. We take I down here, we take I on top. On the numerator, when I multiply I times top, I actually have to look at this as a parenthesis and multiply through like a distribution. On the
So it's a good idea to go ahead and put that.
put a set of parentheses there.
Okay.
Yep. So that'll help you to remember what you do next. Now on the bottom, look what happens. And this is kind of, once you see what happens on the bottom, you'll see why we did this. We get 2 and then I squared, right?
It's -1.
And I squared is going to turn into a -1. In the numerator, when we multiply the I through, what's 3 times I? 3I. And then what's I times I? I squared, so plus I squared. And on my next line, I'll write out 3I. What was I squared though?
Why is it negative?
You know what? I have no idea why I put -3I.
3 negative.
Probably because I'm sleep deprived right now.
So 3I plus
3
I
minus
squared
But I squared is
minus 1.
-1, so it'll become -1 over 2 times, right? This is 2 times -1, so -2. And we're done. Now, you may be saying to yourself, like, well, why even do all that, you know? Like I started the problem with this, didn't I? I'll write it down again.
So you put the i's up first, after the equal sign,
Say again?
you put the I up first, that's what you wrote.
I multiply the top and bottom by I. The black right here is the original problem. The red is what I'm going to do to divide.
Right, but the equal sign, and then the first thing you put up there, on there was I,
Yes.
and then you.
Yes, I just put them there and then
Right.
I distributed.
Okay,
Now, but look at these 2 answers. Like this one was a fraction, right? And this one is a fraction also. So you might be saying to yourself, well, why even do this, right? Like, what's the point? The idea behind division is just so that your denominator no longer has i's in it. That's what we want, right?
So basically the aim is to remove the I from the denominator.
The aim is to remove the I from the denominator,
So your final answer is up there.
right there,
Yes.
This down here is,
The original.
what I started.
Regardless of what the numerator is, there is no I in the denominator.
Yep. Yeah, I don't care about this anymore. What I care about is the bottom, there are no more i's. If we do that, then we have divided. Okay? Let's do one more. How about we do negative 12 minus 7i over negative 5i. So divide that. So right now I do have I in the denominator, right? I don't want that. Why don't I want that? Well, don't worry about it, right? Remember I told y'all last class, like complex numbers, I talk about how they're just kind of weird and we use them way later in math. Just to, for now, we just kind of look at them a little bit, mess with them a little bit, but to understand why you wouldn't want an I in the bottom, just kind of beyond the scope of this class.
so that numerator, are we gonna add? Or just,
We're going to do exactly what we did in the last problem. We're going to multiply the top and bottom here by what? By I. Why does that work? I mean, what's the point of coming in here, I on top and bottom?
Because when you do one thing to one side, you do another.
You have to do to the top and bottom, right? But why do I choose I, not 2i, or why not negative I? Why am I doing I?
So it's not even really negative 1.
Yeah, see, because the I here and the I here, I know are going to turn into negative 1. So that's why I come in with an I. So now I have I squared. All right, so let's multiply this on the top. I'll put my parentheses. I'll have to distribute through. On the bottom, what am I going to get? Negative 5 I squared, right? On the top, negative 12i minus 7i squared. Now, in walking around last class, in this class, and in my other class doing examples, I noticed a lot of students were changing all the I squareds into negative 1s. Okay, everyone's like, oh yeah, that's a negative 1, negative 1. But then they were forgetting that it was multiplication. So they were writing it like 7 minus 1 and making it a 6 or something like that. Or here, you know what I'm saying? Like making it subtraction instead of multiplication of a negative. That's what it is. So this becomes negative 12i minus 7 times negative 1. So I'm going to put the negative 1 in parentheses like that. That's implied multiplication there. That means we're supposed to dot that, not add or subtract. And then on the bottom, negative 5, and I will multiply times negative 1. Everyone comfortable with where the negative 1's coming from? That's it. Now figure that out. Negative 12i. What is it?
Plus 7.
Plus 7 over
5.
5. Done. As soon as our i's out of the denominator, we're done.
So that's what we're looking to do, just take the I out of the denominator.
Now this may seem like, okay, well, I got it. It gets a little bit harder as the next example is going to show. How about this? 1 plus 2i over 1, no, I'll make it 4, minus 3i. What's different about this problem? Good, 2 terms in denominator. Last time we just, last 2 problems I just had like, negative 5i or just a number with an I next to it, 1 term. Now I have 2. Now don't write this down, but let's just talk about why this is not going to work this time. Why will this not work?
Because you'll still have an I at the very end of the equation.
Okay, if I multiply my I through here to the 4, I'll have 4I, right? Here to here, there I'll get my I squared, which will turn into -1. But I'm still going to have an I down there with the first multiplication through, 4I. So it's not going to work. You see that? So what we come through with is going to be something different. So if we have just one term in the bottom with an I, then we come in with just an I and we're done. But if we have two terms like this, what you come in with has a name. It's called the complex conjugate. But all you need to remember it as is you're going to multiply top and bottom by whatever you see down here, change the sign between them. Just between them, not both signs, just the sign in the middle of them. That's known as the complex conjugate.
Always change, okay.
Always change the opposite of the sign in the middle. So had this been a 4 plus 3i, I would have come in here with the what? 4 minus 3i. Now, you might be saying, well, what? Okay, why is that going to do anything? Well, let's see what happens. Now, you have to realize that the top and bottom, the multiplication is going to require foiling out. So it's going to be a lot of multiplications. Let's do the top first. What's 1 times 4? 4. Okay. What's 1 times 3i?
2, 3i.
1 times anything is itself? 1
Oh,
times?
1 times, I thought you
One-
said 2 times
Nope.
3.
Sorry. 1
1
times,
times 4, and you did
that's
1
this.
times
1 times 3i. Now, 2i times 4 would give you what? 8i. And then right here, what's 2i times 3i?
3i squared.
6i squared, right? 2 times 3 would give you the 6. Is that okay? Do the same thing now on the bottom. Do your foiling out on the bottom. 4 times 4, 16. 4 times 3i is 12i. Now this is critical. Watch what happens here. Negative 3i times positive 4. Negative 12i.
They're going to cancel.
They're going to cancel. Yes. And then be real careful on your signs here. What's negative 3i times positive 3i? Negative 9 I squared. All right. So now I'm gonna start with the top, the numerator, and put things together here. I have, these are like terms, right? 3i and 8i is 11i. So I have 4 plus 11i. And then over here, this I squared turns into a what? Negative 1. Multiply it times the 6, negative 6. On the bottom, 16. Okay, what happens to those i's here? They cancel. And look, if you do this correctly, if you always come in with the conjugate, complex conjugate, you will always get your middle terms down here to cancel. It will always happen, which is why we do it. Now this last one, be extremely careful with the signs here. The I squared becomes negative 1, but then you already have a negative 9, and you're going to multiply. So plus 9. So I have plus 9 down. Nothing in the middle, right? It all canceled out. So I'm ready for a final answer here. I am going to collect my 4 and take away 6 to get negative 2 plus 11i over what?
7.
16 plus 9.
16 plus 9 is
I was waiting for 27. Yes, that's it.
25.
Wait,
25. I was right.
Wait, so
16
who
plus
said
9?
27?
I said 25.
All right, all right.
I was
What's 16 plus 9? 25?
I thought you were making up a new rule or something.
Not today.
like instead of put it, take one of 16, like take one number from 16, add to 9, not both together.
Okay, so, when it's two terms in the denominator, that's when you're going to recognize that you need to,
Use the conjugate.
Yes.
which is conjugate, what is that definition?
It's just the same thing with the sign between them changed.
Okay.
So it's whatever
So
you see,
in the
whatever the two
denominator,
terms
you're
are,
gonna change
change
that
the sign in the
sign
middle. And that's
and
it.
put the same thing up on top of it.
That's right. Top and bottom get the same thing. All right, that is it for the operations with the complex numbers, all right? So I'm going to give you a couple more problems here. Page 639. If you look at 49 through 59, odd. That's it.
You want us to do this now?
No, that'll be homework.
Oh, okay.
That'll be homework. Now, before we're going to see I again in a little bit. It's going to pop its head up when we're doing some problems, solving equations. But I wanted to show you all something real quick. We talked a while back about that number, right? What number was that? Pi, right? Pi. We said it was approximately 3.14, something like that. And the definition of pi is if you take any circle and you take the distance around it. What do we call the distance around a circle? Anyone know?
Circumference.
Circumference, okay. If you take the circumference of that circle and you divide the circumference by the diameter, which is the line that goes all the way across. So if you were able to measure the outside and divide it by the line that goes straight across through the center, which is the diameter, your answer will be pi. So you could say that pi is the ratio of the circumference to the diameter. That's what pi is. We just learned this number, I, which we said by definition was the square root of -1, remember, right? That's the way we defined I. How many of you have seen this number? E. No one ever seen E before?
In chemistry.
Chemistry? That might be different. That might be this E.
Or physics.
Usually like E, if like on, are you talking like on a calculator? Or?
Yeah.
Yeah, on a calculator, if you like have 4E,
It's like 4 to the
10,
10th.
that means like 4 with
To the
10
10th.
zeros behind it. That's a different E. This is for, this basically tells you how many places to move your decimal. And if there's a -10 here, you go to the left 10. If it's a positive 10, you go to the right 10. This E is different. This is called the natural exponential. It's basically about 2.718. Just like pi is about 3.14, this number E is 2.718. Very, very important number in mathematics. Very important. I can define it, like I defined this one for you. I can define this one for you, but it's a lot worse. It's a lot more challenging to define. Y'all want to see it or not? I don't.
Sure.
Okay, E
Is
is,
she in college algebra?
you will study E in college algebra, yes. But you'll look at it just like a number. It's just a number, that's all it is. But what it is if you take this on a calculator, okay, on a calculator, if I say, hey, right now, on a calculator, plug in 1 into this. You plug 1 in, you get what? 1 over 1, right? 2 raised to what power?
To the 1.
To the 1, so you get 2, right? So if I plug x equals 1 into that, it would spit out 2, wouldn't it? But if I plug in a 2, I would take 1 divided by 2, which is 1/2. 1 plus 1/2 is 1.5. And then get on your calculator and raise it to the second power. So if x is 2, you take 1.5 and square it. Let's see if I have my calculator. You follow what I'm saying? Just plugging in a value of x equals 2. So you plug in is 1.5 squared, right, 2.25. And then if I plug in 3, right, 1/3 plus 1, that's 1 plus a third is 4/3. And then I'd raise it to the third. And now I get, so if x is 3, I get 2.37. And I can keep doing this forever, right? You follow? If I keep going forever, this number over here gets closer and closer to a number. Like, see how it started at 2, now it's 2.25, now it's 2.37. It starts getting closer and closer and closer. And the number it gets closer and closer to is 2.718. Does that kind of make sense? Like, it just keeps going out forever. Just like pi goes forever. Have you all heard that before? Like pi just keeps going forever, never stops. Yeah, it's never going to reach it. But if you could go forever, you get closer and closer to e. Just like with pi, you can keep going forever, but you can never stop with e.
And what does E stand for?
Well, what does pi stand for?
A number.
A number, right? It's just a letter we give to represent a very important number. E is just a number, but anytime in math that we have a very important number, we usually assign a letter to it. For this number, we assign e to it. For this number, we assign pi to it. For this number, we assign I to it, right? Now, there's two other numbers I want to show you that are real important.
So.
Go ahead. Yeah,
So
sorry.
that will never reach 2.718.
It will reach 2.718, but see, e is the number that you get when you keep going. So like, if I go out to, let's say, if I went out to 100, I'll do it on my calculator. I'll do 1 over 100. I'll add 1 to it, and I'll raise it to the 100th power. I get 2.70481. So I'm at 2.70. I'm not even close to this yet.
0, 1.
So I have to go out, 1,000, and I start to get closer.
So what number actually equals that?
Something with a decimal.
Well, what we say in math is that if I want this to go forever, I define E, right? I'd say E, not squiggly equals, which means it's approximate. I say E equals what happens when I let X get huge. So the way we write that mathematically is this. Lim, which means the limit, and then underneath it, X goes to infinity. This is the mathematical notation of what E is. E is the limit. That means what happens when I let X become infinite in this expression. So if I let X become infinitely large, I get E. That's what it is.
You'll never get a number.
You get closer to a number without actually getting there. But it's going to a certain place. Okay, the point is, right now I've thrown 3 numbers up here that we all now kind of have some idea of what they are. Pi's has to do with circles, I is an imaginary unit, E is this real important thing in calculus. And then there are 2 other numbers that are real important that you didn't even really realize were so important. The number 1 is actually extremely important in mathematics. Actually, we just used it a second ago, didn't we? We multiplied top and bottom by I on that problem. Why? Because I over I is what? 1, and multiplying anything by 1 is itself. So it's not changing the problem, it's still maintaining what it is, just makes it look different, right? So I is what's called the multiplicative identity. Very, very important property of the number 1. 1 times anything is itself, right? That's called multiplicative identity. Then the 0 is the other number. And this is called the additive identity. Because isn't 0 plus anything itself? Right? If I take anything, x, and I add nothing to it, what do I get? X. This top one was saying x times 1 is still x. See, multiplicative identity, additive identity. Yes? Okay, so now what I'll share with you is what's argued to be, it's argued by a lot of people to be the most beautiful equation in mathematics. All right? Here it is. E to the pi I plus 1 equals 0. That's considered to be arguably the most beautiful equation in math.
And why is that?
Well, because it's a true equation, just like the equation 1 plus 1 is 2, right?
So it's basically just 2.718 raised to 3.14 I plus 1 equals 0.
That's right. But what it is it's an equation that pulls all of the most important numbers in mathematics together into to a true
So
statement.
all of that equals -1.
This equals -1.
All of that.
This right here. E to the pi I is -1. That's right.
This is
That's
a
right.
college algebra, we'll be learning this.
No, that's not college algebra. E is in college algebra. I is today. Pi most people know from geometry. 1 and 0 are numbers you always deal with. And I'm just sharing with you this equation.
So should I put to the
beautiful.
side the most beautiful number in all of mathematics?
No, I said it's some people's opinion this is the most beautiful equation in mathematics. Yes.
If that equals -1, then has to be 1 plus 1 equals 2.
Oh, that was an example.
No, I was saying, this is an example of an equation.
It's
This is an example of an equation, right, that we all would say is true, right? Well, this is an equation that's true also.
I'm sorry, so I want to prove.
Well, you can come to my office if you want to know why. You basically would be asking me why e to the pi I is -1. That's a whole different story. Can't explain it easily in
That's your
the
credit.
rest of class.
Represent it.
You want to come present to the
No.
class? All right, well, we're pretty much wrapped up the complex numbers. I've shared with you this equation. And now we're going to get into solving equations, which, like I said earlier, is kind of a step back because a lot of us have done solving equations, factoring, things like that. But this will be a good chance for us to do a lot of group work, a lot of you doing math to see where you are with this stuff. So what I'm going to do is I'm going to start in 10.2, which will keep us from having to factor today a whole lot. Okay, 10.2. But next class we'll do a lot more. The square root property. The square root property. So all of what we're going to do right now has to do with solving equations. And I'm going to put a very general statement up here, almost like a picture that I want you to try and burn into your head. Let's say you have something, okay, which I'm going to represent with a box. Squared equals C. And I'm going to put next to this, C is a number. Okay? Something squared equals a number. If you ever have this situation and you're trying to figure out what this is inside, you can always take the square root on both sides of the equation. So you can always come in here and not squaring it, square rooting it. So the thing that's squared, I'm square rooting it. And then on the right side, I do the same thing. But there's one important thing you have to remember. When you take the square root on both sides of an equation, when you do it, when you come in here and say, I am going to take the square root on both sides of the equation right now, when you do that, you must add a plus or minus here. Joan, what happens, Joan, if you don't add the plus or minus? Do you remember what I'd say?
Wrong.
Can't remember? I thought that would stick. Guess not. What happens if you forget the plus or minus?
That means it could either.
You don't remember the school bus? The kids on the school bus? No?
Means you're saying it's just that?
Hmm?
If you don't use it, you're saying it's just that?
If you forget this, planes fall from the sky. Buses fall off of bridges with children screaming and plummeting off a 30-foot, 50-foot, 100-foot cliff because someone forgot to do a square root so the wheel wasn't engineered properly and it fell off and then everyone died. That's what happens.
That's what happens.
No, that's what happens when engineers forget it. In this class, you just cost you a few points. Okay? But that plus or minus says that there are going to be two answers. One of them is plus this, and one of them is minus. That's the biggest mistake that people make with this, is forgetting the plus or minus. Look, let me show you why it's so important. Look at this example right here. X squared equals 4. What numbers can I square to get 4? 2. 2 squared is 4, but is that the only number?
No,
Negative 2 times negative 2 also gives me positive 4, right? So does this look like something squared equals a number? Something squared equals a number? So I take the square root on both sides.
So it's plus or
The
minus.
square root of x squared is just what?
X.
X, because these would cancel, right? But on the right side, if you just say, hey, the square root of 4 is 2, you only got one of the two answers, didn't you?
Yep.
But had you put the plus or minus, like I said, you get both the positive 2 and the negative 2. So that's just something you have to do every time you take the square root on both sides of an equation.
So it's either plus or minus?
It's both.
Both.
It's both answers.
What kids
Wait,
do.
So you put plus and minus?
Yes.
Yeah, it's plus or minus 2.
Because
It's saying the two answers are positive 2 and negative 2.
negative 2 and negative 2 can also equal 4.
Right.
So could 2 and 2. So that's why it's plus and minus.
So if you want, you could write it like this. You could write them separately, like that, or you could write it with a plus minus in front of the 2. Either way, it means the same thing. There are two different answers here, 2 and negative 2. Okay, so anytime you see something squared equals a number, you take square root on both sides, you do plus or minus, you forget that, children die. You don't want that? Well, maybe you do, but that means you're kind of sick. Okay, so here's an example. How about this one? 2x minus 3 squared minus 9 equals 0. Now, do you have something squared equals a number?
Mm.
I have something squared minus 9 equals a number, right?
want to isolate it.
Yeah, I want to get the thing squared by itself first, so that it looks exactly like something squared equals a number.
So add the
Add the
opposite.
9 to both sides. Now, why did it start smelling like really fruity in here? Like all of a sudden. Is that what that is?
What is it?
Hand sanitizer.
Oh.
Some of those smell terrible. That one smells pretty good. Okay, so now I have something squared, right? Doesn't matter what's squared. It's just as long as I have something squared equals a number.
We need to score the 9 as well.
Well, we'll have to square root now. All I did was isolated it. Now I square root both sides. Plus or minus square root 9. And what happens on the left side?
Both go away.
The squared gets killed off by the square root. It's just like we did before, but it's opposite. When we had square roots, right? When we had square roots, we would square them to make them go away, right? Now when we have something squared and we want to make it go away, we square root both sides.
Could we wait to put the plus or minus until the end of the problem?
I wouldn't recommend it because later on we're going to have more stuff involved and it could cause a problem. What's still here on the left side?
2x minus.
Everything that was under that square root, everything that was being squared, right? 2x minus 3. That's the only thing left. On the right side, what do I have?
Plus or minus.
Plus or minus
3.
3, because the square root of 9 is 3, isn't it? Now, I still have not solved this equation. I'm trying to figure out what x is. So watch what I do now. I'm going to take this 3, get it out of here by adding it on both sides, right? So when I add 3, I have to add 3 over here. But this is kind of weird. Do I add 3 to the positive or do I add it to the negative?
Both.
I'm going to have to do both, but I'm going to wait on that. So watch the way I write this. I'm just going to write 2x equals plus or minus 3, and then what am I doing, adding 3? So I'm just going to add that 3 out to the outside. like that. I'm not actually going to do the addition yet. Got it? Questions? Now I need x by itself. How do I get rid of the 2 in front of the x?
Divide both.
Divide both sides by 2. So now I say x equals plus or minus 3 plus 3, everything divided by 2. And now what I'd like to do is look at my 2 cases, right? One of them is 3, positive 3, plus 3, then divide by 2. The other one is negative 3 plus 3, then divide by 2. So I like to do it this way. I like to put a little equals. I like to draw 2 little arrows like this. One of them is what happens when it's plus, and one of them is what happens when it's minus. Does that kind of make sense? I'm going to do, okay, if that's the plus 3, here's what I get. 3 plus 3 over 2. What's 3 plus 3?
6.
6 over 2 is 3. So I get an answer of 3. If I let if I let it be negative 3, I get negative 3 plus 3 over 2. What's negative 3 plus 3?
0.
0. 0 divided by 2,
0.
0. So my 2 answers are 3 and 0.
So you got 3 plus 3 is 6, and then you just divide it by 2 times.
Yep. So remember, you got to do what's up here first, though. Okay? You can't divide over like this. You got to do everything up top first, then divide by 2. That make sense?
Yeah.
Okay. I don't know how, but we still have a long way to go here. Dragon. How about this?
You just kick us out early.
Yeah, I could just cancel it and stop, right?
Take your tail.
Who'd want to do that?
I would.
How about 2 minus 5x squared? Plus 20 equals 0. So do you see something squared equals a number?
Yes.
Yes, kind of, right? You need that 20 there not to be there.
We do subtract.
Subtract. 2
Oh, man.
minus 5x squared equals negative 20. That's what happens when you take that 20 to the other side. And I heard, oh man, because you see what's going to happen here.
What?
It's a square, so it's not.
Oh, I was gonna ask you about that, the other problem.
I need to take the square root, right? I'm going to take square root on the left. I'm going to do plus or minus. On the left side, I get 2 minus 5x. That's all that's left. But on the right side, I have plus or minus the square root of a negative number. And that would have been homework from last class, right? Square root of, I'm going to do it over here. Square root of negative 20. What you can do is break it up. Negative 1 times, square root of negative 1 times, square root of negative 1 times square root of 20. Splitting the negative 20 into these. Square root of negative 1 is what? What is that? I.
Oh, I, sorry.
And then what's this? 20, you'd have to break that down. 4 and 5, square root of 4 is 2. So this becomes 2 root 5, doesn't it? And that's really 2i root 5. You'll see that work involved there?
Yeah.
Now that's just the right side. So I'm going to come back over here now and I'm going to put plus or minus 2i root 5. Now I'm trying to solve for x, so how am I going to get x by itself over here?
Close to 2.
Take that 2 out of here, so not add it, but subtract it. I'm going to have to leave this over here. So when I subtract 2 on both sides, here's what I would get. Add this 2i root 5. I'm going to take 2 away from it, right? But I can't do that. I can't take 2 away from this because it's plus or minus, and I can't do that until the very end.
Why didn't you do -2 on the left and then +2?
I did it mentally. -2 here is gone, right?
Okay, -2 and then -2,
On this side, which is here.
that whole term there.
This is what was here. I'm taking 2 away from it.
So I could put 2 underneath of it, -2, under the 2i squared 5.
You could put it down here like this. I don't know if that's what you mean. Cancel it.
Oh,
And then
right.
over here, this is what it would turn out to be, though. What now, though?
You would
Divide both sides by -5. So I come in here, I divide the left side by -5, the entire right side by -5, to give me this. X equals plus or minus 2i square root of 5 minus 2 over -5.
What is it? That's the answer.
Yes, you can. The reason why you can say it's the answer is because you cannot put these two together. They're not like terms. This one has i's in it in square root 5. You cannot combine that with a 2. In the previous problem, right, we had 3. It was either 3 plus 3 over 2 or it was -3 plus 3 over 2. We could put those together and we got 2 answers, didn't we? Here you can't combine the top. So now this is what our answer is just going to look like. So the solutions to this equation are imaginary numbers. So there's no real solution to this equation. We would have a long time ago stopped right here because we would have had the square root of a negative number. We said we can't do that, right? Now we can. And so we get our imaginary solutions. Make sense?
That's gonna get some practice.
Yep, and you're going to get practice when you get home.
So for this one.
The final, this is it for, that's what you do if you have something and it's squared equals a number, right? That's what you do. Now, what if you have this? What if you have, now these I'm just going to give you an example. What's the difference between this problem and the one we just had? Do you have something squared in a number? That's right. You do have something squared, don't you?
Oh,
You do have something squared? But you have, the other thing is not a number. I mean, it is, but it's what's attached to it. The variable. So this is not what we just did, right? And so we have a different way of doing this.
Divided by 5.
You can divide out of 5. How about looking at the left side? Don't we have like a GCF, greatest common factor?
5.
Don't they both have an X in them? Both have a 5?
5x.
So just pull a 5X out. You'd be left with what?
X minus 2.
Then equals 0, right? And now, once you get to this point, if you're saying that this 5x times x minus 2 equals 0, that means one of those has to be 0. Either the 5x is 0 or the x minus 2 is 0. So you set each factor to 0. This is actually, I think, easier than what we just did. Because all you have to do is take the 5x now, ask yourself, when's that 0? Then the x minus 2, and say, when's that 0? Solve both equations. So what do you get?
It's 2.
X is 2, that's this one,
And
0.
and 0. Divide both sides by 5. Doesn't that seem a little cleaner than what we did just a second ago?
Yes.
What did you, x equals 0?
Divide both sides by 5. Divide this side by 5. So that's x, and then 0 divided by 5 is 0.
But you didn't do that with the 2.
Well, it's not multiplication though, right? That's subtraction. So here I added 2 to both sides, here I divided. Yeah. So you have to pay attention to what the operation is between the x and the number that's there. If it's addition or subtraction, you'll add or subtract. If it's multiplication, you divide. Okay, how about this one? See if I can get you on this one. I get a lot of people on this one. So is that something squared equals a number?
Yes. Not until you divide it again.
Something squared equals a number. Well, I have something squared, right? Do I have a number?
No,
No, it has a number with a variable, right? So this is not something squared equals a number by itself. Had this been an 8 over here, then I could do it. Do what we did before. But it's not. So what do you think we're going to do? Like, what did we do over there?
You're gonna
We factored, right? Just GCF?
So it would be 2x. No.
Well, they're on opposite sides of the equation right now.
7 to equal 0?
Set it to equal 0. Move everything over to one side? Yes, that's correct. So I'm going to move the 8x over. So the negative 2x squared is here. Moving the 8x to the left makes it a negative 8x, right? Is that all right? Okay. Now look at the left side. What can you pull out of both of those terms?
Negative.
Negative 2x. You could have pulled a positive. That's okay also. What would be left here?
X plus 4 goes.
X plus 4 equals 0.
And then those.
Set those both to 0. As soon as you've got them pulled apart and factored, you can set both factors to 0. So you get what? This first one, x is what? 0, and then this one is negative 4. This make sense? Now I'm going to summarize what we just did, all right? I'm just going to summarize this. Both techniques. Okay, if we had something squared equals a number, right? What did we do? Square root, right? Once this was isolated and stuff, we would just do square root, both sides. Always remembering plus or minus, right? Don't forget that. And then just work it through, right? That's what we did. This was different though. This was like, this is our separate thing. This was like we had something squared, right? And it would have like an x in there. And then I'd have like somewhere else, it may be a plus or minus, I had something else, I'm going to do a triangle, but it would have just x, right? So this one has x squared, this one had an x. Does that make sense this way? Here you have something squared, of course there was an x in here, but it had, something squared is just a number. Here we had the squared term, but we also had an x term separate. If we could get that equal to 0, how did we do that? How did we solve that? Factor GCF. Right? And then we set each one to 0 and solve. So we have 2 techniques so far. We good?
Yes.
All right, because that leads us to our last technique. And what? We've got 15 minutes, right? I know you're tired. I'm tired too. But the more I can do today with this next technique, the less we have to do next time. So I'm going to put 3 problems up here on the board just so you can see them, so we can see the differences. Okay, look at those 3 problems.
Something squared equals a number.
Okay, this first one is like the first thing we did. We have an x squared, right? And we have a number. So we could move the number to the other side, couldn't we? Then do square root on both sides. So this one we know how to do, don't we? I'll just put it over here. You don't have to. X squared equals 9. Square root on both sides. Right, that's what we would do. This one could we do?
Yep.
Yes, because we have x squared, then we have an x in here, right? And so what we would do is GCF. And then we set each of those equal to 0, right? I'm not going to work it out. Yes?
Yes,
Okay. This one, though,
we can't use.
you can't do the first technique, right? And you can't do the second technique. The reason you can't do the second technique is to be able to pull a GCF out, they must all have the same thing, right? They don't all have an x. So the big difference in this last one is the fact that we have an x squared term and an x term and a number, right? Here's x squared, just a number, x squared and an x term. Here's x squared and an x term and a number. Yes? Okay. So the question is, how do we solve this? That's where we are. And you've learned to factor that with AC method, right?
Right, you haven't done one myself today?
Well, the one you asked me about for homework, I did wind up with a quadratic equation, didn't I? So you should have some background with this. So, put a question mark next to that. The last 10 minutes or so, I'm going to show you something called completing the square. This is in this section. How many of you have seen completing the square? Completing the square? Yeah. That's what I want to show you. However, before I get into that and show you, and I'm running out of time, how many of you have ever seen this formula? I'm going to put it here. It's going to be off screen. ax squared plus bx plus c equals 0. That's a standard quadratic equation. And we have this thing called the quadratic formula. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Show me your hands. I know you're tired, but show me your hands if you've seen that formula before. No? Yes? Everyone has pretty much seen this? Okay. This is one of the fundamental equations that we use to solve quadratic equations. All right? Does anyone know where this formula came from? Y'all heard of Moses? Burning bush?
Yes.
10 Commandments?
Yes.
The other side of that had all the math formulas that we needed, right?
Exodus.
No?
You
don't believe that?
I thought someone else came up with that.
Yeah, no, I'm kidding.
Oh, okay.
We did. We did. I'm actually going to show you where the formula comes from right now. Because I'm not a big fan of completing the square. In a course like this, I'm not. But if I can show you how to use this to create this, then I'll let you use this all day long. But you gotta let me show you how to get this. All right? So I'm going to derive the quadratic formula for you. That way you always know, okay, yeah, I know it comes from somewhere, and my teacher one time showed me where it came from. So here's what I'm doing. What I need you to do is try your best to follow me. All right? Here's an equation. This is called a quadratic equation. A, B, and C here are just numbers, okay? They're just numbers. So A could be 1 and B could be 9. It doesn't matter. They're numbers.
This is following the last.
Yeah, the last one we couldn't figure out. Exactly. So I'm going to try and attack it by attacking one that's a general equation. All right. First thing I'm going to do is divide the entire equation, everything, by A. Am I allowed to do that? All I need you to do is tell me thumbs up, thumbs down on each of these steps, if it's okay or not. Can I divide everything by A? Here, 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 here. A is not 0, right? A is a number. I can divide anything by anything but 0. So let me divide everything by A. If I divide this by A, what happens? A's cancel, just becomes x squared. Over here, I'll have the bx divided by A, won't I?
AB.
I'm going to put it like this. B over A in front of x. Isn't that the same? That the same?
Very different from what I'm used to.
Well, let's say that had been a 4x, and I was dividing by 3. That's the same as 4/3 times x, isn't it? Go by that? Okay. So I'm just writing, because b and a are numbers, I just put them out in front of the x like that. What would I have at the end? Plus what?
Plus C over
C over a equals what's 0 divided by a?
0.
0. Okay, so far, do you follow? Okay, next thing I'm going to do is extremely awkward, but you just tell me whether or not it's okay with you, all right? You're never going to have to reproduce this, okay? I just want you to see that it wasn't Moses with the tablets where this came from. So now what I'm doing is I'm take the number in front right here. Take that number by itself. Just bring it over here for a second. And what I'm going to do is I'm going to multiply it times 1/2. Bear with me. Multiply by 1/2. And I think what I'm going to do is I'm going to kind of put a little arrow under that. That's an important step, all right? What would you get if you multiply that by 1/2? So multiply straight across. B times 1 is B. A times 2 is 2A. So I get what, and I'm going to box this, I get what I'm going to call my first magic number. Okay, it's just a magic number. Like, and if you're sitting there and go, why in the world is he taking that and multiplying it by 1/2? Don't worry about that yet, all right? You're going to see what this is going to work out. Now take this number and square it. So take your B over 2A and square it. Now this is all scratch work I'm doing over here, so I haven't done anything to this, right? Square that, what do you get? B squared on top, square the bottom. You have to square both the 2 and the A.
2 squared.
4,
4 times
and then A squared. All right, next thing. I want to come back over here now, so now I need you to really pay attention whether or not I'm breaking any rules. Is this the same? Do you agree that whether or not this is the same problem or not? Is this the same? If I take that equation right here, and right in between these two, I put a 0. Is it the same thing? If I add a 0?
Yes.
If I add nothing, does it change anything? Doesn't, right? So that's the same, right? Okay, here's the really kind of crazy part. If I take that 0 in there, and instead of it being 0 like this, I take this number right here. That's just a number, right? B squared over 4A squared. I don't know what it is, but it's just a number. I'm actually going to add that B squared minus 4A squared and subtract B squared over 4A squared, and then put plus C over A equals 0. Have I changed the problem? Why not? Because this is a 0, isn't it? This is still 0. Something minus itself is still 0. So I have not changed the problem. It's still the same.
But why did you put minus?
Well, if I'm going to add something, I have to take it away for it to be a 0, right? All right, now, I need a little bit more scratch work. I still have 5 minutes. Y'all hang in there. I would like for us on the side here just to do this real quick. What's x plus b over 2a squared? What is that? Well, we have to FOIL it, don't we?
X
Yeah. Wake him up. Hey, I consider that just disrespect. All right. You can go if you want to go. Just don't sleep.
No, just
I understand.
do.
Okay, x times x. X squared. Okay, this is going to be weird. Here times here.
Well, hold on. X next.
I've got to go faster. You can watch this again, okay?
All right.
B over 2ax is what the next one would be, right? The inside one would be plus b over 2ax again. And then the last one would be b squared's on top, and then on the bottom, 2a times 2a is 4a squared. What would I get if I put these two together?
you would get 2b
2b,
over 4a.
For a,
you don't add these though, hold on. If I take b
This-
over 2ax and add it to b over 2ax,
So just 2b over a.
2b over
a
2ax.
x.
So it'd be 2b over 2ax. The 2's cancel and I get what? b over x. b over ax. So these two together are b over ax. We're almost there. I've got 3 minutes. These two together are b over ax. So do y'all see what this is? X squared plus b over ax plus b squared over 4a
Yes.
squared. Do you see that that's these first three terms? Y'all see that? Yes? So this is the first three terms. So I'm going to write that out over here. So this equation right here, what I just put in this bracket, is really what? X plus b over 2a squared. Now what do I still have sitting out here though? What have I not put out here? Those two, right? Those two? Now I'm going to take them to the other side of the equation though. When I take this to the other side, it becomes a what? Positive b squared over 4a squared. And then this one comes the other side and becomes a minus c over a. Still there? Some of you, I know if you start falling off the boat, it's okay. As long as a few of you follow me, that's okay. Now, do I have something squared equals a number?
yes.
Oh.
Do I? I have something squared equals a number?
That's what you gotta get it to.
Yep, that's what I'm trying to get it to. So now I take the square root on both sides. When I take the square root over here, what happens?
Cancels out
X
on the left
plus
side.
b over 2a. Over here, what do I get? Square root, but then I have to do what? Plus or minus b squared over 4a squared minus c over a. I have a minute and a half, if you're still with me. I'm going to get a common denominator here. Common denominator. How do I get common denominator? I would need to introduce a 4a on top and bottom so that these both have 4a squareds on the bottom. So what would that become? X plus b over 2a equals plus or minus square root. Since they have the same denominator, wouldn't it be b squared minus 4
4c a
4ac, b squared minus 4ac all over the common denominator, 4a squared. Right?
Why did you change it to AC?
Well, because this is where I'm headed.
Descending order.
Well, because I'm trying to get you to see I'm almost at this
Okay.
formula. I'm almost there. Now what I'd like to do is take this and split top and bottom, root on top, root on bottom. What's the root on top? Well, I don't know what the hell the root on top is. It's whatever that is, right? But the square root of this is what? What's square root of 4?
2.
The square root of a squared?
2a.
A. So that becomes 2a, right? Now move this to the other side. Just pop it right out in front of this plus or minus. And you get x equals negative b over 2a plus or minus square root b squared minus 4ac all over what? 2a, but those both have 2a's. So put them together and you get this.
So you just derived the quadratic.
I just derived the quadratic.
I could have done that all last semester. We got like 20 points on a test.
What? Oh, that was extra credit or something?
Yeah.
Yeah.
If you derived it.
So I guess here's the moral. We got to go, and I got to give you homework. The idea for me is this. Look, quadratic formula is very powerful. We're going to use it extensively, but I wanted to show you where it came from. Because anytime I can show you a formula and where it, that it didn't just fall out of the sky, I think it's worth it.
Is that
Okay.
gonna be on our homework?
No.
Okay.
That would, if anything, be a bonus problem. Derive the quadratic formula using completing the square. 17 through 39. Hold on. Yeah, 39. Odd. That's it. Have fun. We need to do a quiz. Maybe we'll do one next time. Thing is, you need a quiz grade, don't you?
Wait,
I
so,
haven't done your test corrections. That's going to take me probably until the next test to get those back to you.
wait, so, there was this quiz on Wednesday now?
I would expect a quiz on Wednesday. Yeah, because we need to get some quiz grades, you know?
So you can pass those corrections back to